Hello my students, welcome back to our session. We are still under factor affecting velocity of sound in air. This time we are going to talk about humidity. I think in Form 3 you learn about vapor and humidity, but also in geography you learned about humidity. Humidity is nothing, is the amount of water vapor into the atmosphere. Now let us assume the amount of water vapor is increased into the atmosphere or into air. Amount of water is increased. If you increase the amount of water, that means you increase the volume of particles. That means now the volume of the particles is increased. Now, do you know what's happened when you increase the volume of particles? When you increase the volume of particle, when you increase volume, that means you increase vibrations. That means you increase volume. That means you increase vibrations. Humidity increase when the amount of water vapor is increased, you increase the volume of the air because it will come and take a space. But also, if you increase volume, that means you increase vibrations or you increase collisions. What if now vibration increases, the volume increases? What's happened? The decrease. Volume increase, vibration increase, decrease in density. The density is decreasing when we have when you increase the amount of water vapor. Now this means the density of moist air is smaller than the density of dry air. The density of moist air is smaller than the density of dry air. Now, due to this factor, due to increase in humidity, the density of air decreases. Now, when the density of air decreases, this means that it increases the speed of sound in air. Speed of sound or velocity of sound increases. Velocity of sound increases when there is high amount of water vapor into the atmosphere. But also there is practical application of this one, that velocity of sound increases when there is increase in amount of water vapor in the atmosphere. Do you know what it is? This is concerning about silence and whistle of the train. Silence and whistle. During rain season, whistle of the train transfer a very large distance. Why? Because during rain season, there is high amount of water vapor into the atmosphere. By doing so, the velocity of sound increases. That's why during rain season, whistle and the silence of trains travel through a very large distance or a very longer distance. Mathematically, we can treat the case of humidity by comparing the densities. Now let us assume M stands for moisture, and the D stands for dry. Now this is to say that when you have velocity of sound in dry air is inversely proportional to its density, to square root of its density. But also, velocity of sound in moist air is inversely proportional to its what? To its moisture density. Due to this, combining these two equations, we are going to have velocity of the dry air divided by velocity of moist air is nothing but under root of density of moist air over density of dry air. This is what we should note under humidity concern. Now, after that case, we're going to look wind. Another factor which affecting the velocity of sound in air is called wind. Wind, if air is blowing, the blowing air is wind. If air is blowing if the air is blowing, that means the speed of sound is changing. The speed of sound is changing. It can decrease, it can increase. It depends on the direction of wind. Now, if the direction of wind, this is direction of wind, and the direction of sound, which is V, are the same, that means the speed of sound in air will increase. That means the net velocity will now be equals to VW plus V. But also, if the speed of sound, if the speed of wind is in opposite direction with the direction of the speed of sound, that means the speed of sound in air will decrease, and now its net speed will be given by V minus VW if they are different. We can take a simple example, as for example you are running through the stairs. When you run according to the direction of the stairs, that means you are going to the direction of stairs. You will see as if you are going simple. It is simple. That means your net speed will increase. This is like this one. But if you are going against it, you are going. There will be an increase of time for you to reach a certain point. You are going against the stairs. That means it is like you are going against the wind. Therefore, the net velocity will be what? Decreased. You are going along the stairs. That means you are going in the direction with the same direction of the stairs. That means your velocity will do what? Will increase. This is what to note. But it can happen the wind direction is at an angle. The wind direction is at an angle. For example, this is the direction of, let us assume this is the direction of sound, V. Sorry, let me use this way here. Sorry. I use here. The wind direction and speed direction, they're at an angle. Now this is speed direction and this is wind direction. They make an angle theta. This is speed, this is wind VW, and this is sound wave speed. Makes an angle theta and in the same direction, but an angle. The same direction at an angle. Now, how can we find the net speed under this part here? This is simple. What we should know is to use the mathematical operation to resolve the vertical component and horizontal component. Look here. The vertical components will go down, and this one here, the horizontal components of VW, which will go this side. Now look, this is opposite, this is opposite, this is hypotenuse, therefore this is sine. Vertical component is sine, therefore this is VW sine of theta. If I consider this horizontal component of VW, it will be VW, which is hypotenuse, and this value here, which is adjacent, will get VW cos theta. Now, which component are we going to use? We're going to use the component which is in the same direction with the direction of the speed of sound. The component which will be used is VW cos theta, not V sin theta, because VW sin theta is in opposite direction with the direction of what? V. Therefore, what can we conclude? V net for the sound will be equals to V which is this one, plus VW cos of theta. But again, it can happen the speed of wind is at an angle but in opposite direction. The speed of wind is at an angle with that of sound, but now in opposite direction. Let us assume this is VW, which is acting here, but that of sound is acting in opposite direction with that of wind at an angle theta. Don't worry, we're going to find out the component of VW. This one will go this way, this one will go this way. Therefore, this is VW sin theta, this is VW cos theta. Now, which one is horizontal components of VW? Which and which? This VW cos theta. We are not going to use this one. Therefore, V net for the wind which is in opposite direction at an angle with V is given by V minus VW cos theta. Therefore, it depends on the question which we'll be asking. This is for the case of wind. Another factor which affects the speed of sound, which the speed of sound depends, is called pressure. What will happen if this is the air molecules? We assume this is air molecule. When you have an increased pressure into these air molecules will be squeezed. That means its volume will decrease. Now, if the volume will decrease due to high pressure into the molecules, what will happen? The decrease in volume leads to the increase in density. When the volume decreases, the density increases. Now, what does it mean? When you have pressure increasing, we are going to increase density. When pressure is doubled, this means when pressure is doubled, we are going to double density also. Now let us go back to our equation. Our equation is saying how? Our equation is saying V is nothing but under root of atomicity P over density. Now, wherever pressure is increased, the density is increasing too. Wherever pressure is doubled, the density is doubled too. What does it mean? This means the ratio of P of density is remaining constant. The ratio of P of density, if it is 20, will remain 20, even though there is pressure increasing, pressure decreasing. What conclusion can we say? Since this ratio remains constant throughout what we are doing, this means that pressure has no effect, because this is constant value, does not change. This ratio is constant, does not change. If it is not changing, what does it mean? Pressure has no effect. To velocity of sound in air. That is what we should know. Pressure has no effect because the ratio of pressure and density remain the same throughout, even it is increasing or decreasing. The last factor is frequency. Frequency, let us recall from the general wave equation, which is saying wave velocity is nothing but frequency times wavelength. Remember, the velocity of sound in air is the same, which is ranging from 330 to 340. This is the constant value, meter per second. Now, if you change the frequency if we disturb the frequency, if the frequency is disturbed, either by increasing or decreasing it, automatically you are going to disturb wavelengths. If you increase frequency, you will decrease wavelengths. Why? Because for this value to remain the same. If you increase frequency, the wavelengths will decrease automatically. Why? Because 330 must remain to be the same. If I'm going to decrease frequency, I'm going to increase wavelengths automatically. Why? Because 330 must remain constant. Now, what can we say? This means that frequency also has no effect. Has no what? Effect. Because even though it will increase or it will decrease, still the velocity of sound in air will remain to be the same. What the effect of frequency is just on wavelengths. That means if frequency increases, wavelength decreases. To overcome the effect of velocity, that means to make sure velocity will remain the same. Guys, hope you have understood the concept. This is the end of the factors affecting the velocity of sound in air. See you in the next lesson. Bye.